As we work to develop the problem-solving abilities of our team, we want to move from big, vague concerns to root causes that we can use countermeasures to try to address. We start tackling our big, vague concern by really trying to grasp the situation by going to Gemba. We go see, ask why, and show respect. During our go-sees, we compare what's actually happening with the standard and the ideal. So do we have a cause gap where actual performance isn't meeting a standard? Or are we meeting our current standard but challenge ourselves to raise the bar? This would be the creation of a gap or a created gap. Once we understand both our current and target condition, we can start to dig deeper in our analysis. If we're using an A3, this is where we focus our time on the left-hand side of the A3 as we make sure we have the right information to inform our experiments. To do this, we can choose to employ what's called the 5 why analysis as we work to better understand the root causes for our waste. 5 why analysis simply suggests that you ask why at least 5 times as you work to understand the real underlying issues. And children are great at this. Why? Because they are working really hard to understand the world around them. We need to channel this same sense of curiosity to truly understand. Root causes for problems typically fall into one of 3 categories: an inadequate standard, inadequate adherence to a standard, or an inadequate system. So here's an example from Lean Production Simplified by Pascal Dennis that refers to an old example from an engine plant. The station produced 900 units versus a target of 1,200. Why? Because the robot stopped. Why? Because it was overloaded and a fuse blew. Why? Because the arm wasn't properly lubricated. Why? Because the lubrication pump wasn't working. Why? Because dirt and debris got into the pump shaft. Why? Because the pump motor was designed without a filter. So in this case, this could be an inadequate standard because we didn't realize that the pump motor should have a filter to prevent debris from getting into the pump shaft. Or it could be an example of an inadequate adherence to a standard, if the motor should have had a filter, but we didn't follow that. We see this in the operating room. A required supply was missing on a case cart. Why? Because someone grabbed the wrong supply. Why? Because it was mislabeled on the stock room. Why? Because a new OR tech mixed up the numbers on the shelves. Why? Because the SKU tags in the shelves are very small. So this actually happened, and it happens a lot across large, complex organizations. Now, to do this well, you need to keep a few things in mind. First, be careful of your tone and intention. Instead of one person asking all of these questions to another, try getting a team together and asking the questions together. This should never be accusatory. Instead, investigate the process and system together. Also, make sure the answers are based on facts observed at the Gemba. This prevents the 5 why session from becoming a brainstorming process, which can lead to a massive number of possible causes and create unnecessary confusion. Instead, work to validate each of these by going and observing the point of breakdown for yourself. While people tend to take the 5 why analysis quite literally, asking why 5 times, it's really more about the purpose. It means we need to deeply question and then confirm what's happening, especially if there was a recent error or an issue that's fresh and can be adequately investigated with the people and processes at the Gemba. It means we want to pursue understanding of causality. And this is some of the difference we see with respect to organizations just copying the tools of Toyota and not the thinking or the purpose. When we're able to ask why at the Gemba and show respect, we are dedicated to truly understanding and improving. And that is, again, the heart of continuous improvement. Slowing down to ask these questions at the Gemba can be time-consuming and challenging work. Deep reflection and scientific thinking are actually not natural inclinations for many of us. They require patience and practice. It's not surprising then that the cognitive psychologist and Nobel Prize winner Daniel Kahneman found that humans have a natural tendency toward what he calls fast thinking. Slow thinking, he found, comes much less naturally and can even feel painful. Fast thinking is intuitive thinking. It's fast, automatic, and based on mental shortcuts or heuristics and biases that result in impressions, feelings, and inclinations. Slow thinking, on the other hand, is rational thinking. It's slow, deliberate, and systematic, and it results in logical conclusions. Slow thinking requires concentration and broad consideration of the problem and potential countermeasures. Next time you or your team is presented with a problem or a challenge, make sure you go to Gemba. When you're there and are working together to ask why, consider whether the way in which the information has been presented has primed you to instinctually move in one direction. Actually work to verify through observation, data, and facts. Then challenge yourself and your team to employ slow thinking as you really work to understand the situation. When done with a team that uses humble, appreciative inquiry, you'll find that you can avoid creating a culture of blame and create a culture of investigating the system and processes that enabled that result. Again, our systems are perfectly designed to give us the results we get. Let's design ours to be better.